Hello everyone, my name is Sebastian from Stellar Tutoring, and today I'll be doing a walkthrough of how to solve this separable differential equation. Now, this is a bit of a tougher one, so I think it would be really beneficial to break it down step by step. So just as a refresher, a separable differential equation is when we have a function, and then we glue it to a differential, this dx, and then another one, and we glue it to another differential, dy, and then we set them on equal opposite sides, and then integrate, right? Because that's just how things are ran in differential equations. Usually we see this in the form dy dx equals something, and then you multiply both sides by dx, it crosses out, and then you can integrate, blah blah blah. But in this case, they've somewhat done the work for us. They've already separated these differentials. The issue is we see that they're on opposite functions. So this is a function in terms of y, and this differential is in terms of x, and the same, well, but opposite over here. So we're gonna have to do a little bit of extra work to separate those. Now, the first step we want to do is just get them on opposite sides. Just like when you're in algebra and you move the x's to one side and numbers to the other side, we can do that here too. So we have cosecant y dx is equal to negative secant squared y, or just negative secant squared x dy. Cool, perfect. Now we can't integrate both sides yet, and the reason is here we have a function in terms of y and the differentials in terms of x, so we won't really get anywhere. And again, same here. So what we have to do, and this isn't really a trick, it's more just both steps. We have to get this on that side and this function of x on this side. So how we do that is just multiplying by the reciprocal. And we can do the whole thing just so you see how I'm doing it. This is going to be multiplied by 1 over cosecant y, and so will this. I'm going to do it, like I said, I'm going to do the whole step so you don't get confused. This crosses out, and we're left with 1 equals negative secant squared x over cosecant y dy. And now we do the same thing over here. We multiply by the reciprocal. 1 over negative secant squared x. Oh, sorry, and I forgot the dx over here. Let's just move it in front. Now when we multiply, this side, or did I write it? This side, what you do to one side, you do to another. So we're going to have something that looks like this. 1 over secant squared negative x dx, and that's good because we have it on one side, is equal to 1 over cosecant y dy. Perfect. We have the differentials and the functions in the same terms and on the same side. Now, it would be great, and you can just integrate these. And if for some reason you know these off the top of your head, then you're done. But these don't really show up on an integral table. There's no real trick you have to do with them. You just kind of have to break them down and put them into simpler terms. So what you do is when you're dealing with these functions, these reciprocal trig functions, cosecant, secant, cotangent, it might be better to break them down into their original forms, their reciprocal forms. So this turns into 1 over negative 1 over cosine squared. Remember, secant is just 1 over cosine. And then this is going to be 1 over sine y. Again, remember, cosecant is just 1 over sine. And let's not forget our differentials. Cool. Now, let's just simplify the denominator. Let's multiply. It's going to be a little bit cramped, but let's multiply this by cosecant squared. What we do to the bottom, we do to the top. Sorry, that's a little bit cramped. This is my first time doing this. And now we multiply this by sine y and sine y. This will cross out, leaving 1 in the denominator, which we just ignore. And then the top now becomes a little bit more easy to work with. So we have the integral of negative and let's just move that negative to the outside. The integral of cosine squared x dx, so that looks much easier to work with. And if you think that's easy, look at this, equals the integral of sine y dy. Okay, this integral right here, you can do integration table. If anything, you might even know it off the top of your head. And if you don't, now you're going to know it. So this is going to give us, and we'll get to this other one in a second, the integral of cosine squared x dx equals negative cosine y. And there's going to be a plus c, but I usually put it on the x side just to make things simpler. So you could put a plus c here. Just don't do it on both sides because it's just going to cancel out. So not cancel out, but it doesn't really matter because they're both arbitrary constants. They're just c's. So we have this. But now, how do we integrate this? You might think a u sub, but that's not going to get you anywhere. You might think a trig sub, but same thing. You might even look at your integral table, and that might have it, but that might not. So what can we do here? When we have an even power, what can we do? Right, down here, you might have remembered our power reduction formulas, right? And I have them both here, both cosine squared and sine squared. Now, the reason I don't have the tangent squared here is because it's pretty easy. If you remember, oops, that tangent is just cos or sine over cosine. You can just, put this one, and I should have done it opposite. I should have put sine on top. But you can do this function divided by this function. So you do this as a fraction, but just flip it. The 1/2 will cancel out, and then you're left with this on the top and bottom, and that's how you can derive it. So it's one less function, or one less identity you have to memorize. But anyway, let's apply this power reduction formula to our cosine squared over here. The negative integral of, and we can also pull out the 1/2, make things easier on ourselves. 1 plus cosine, double of whatever is inside the cosine. So 2x. You can think of it, we're dividing this by 2, in exchange we're doubling this by 2, right? And now a way you can memorize just one of these is that I like to think, cosine and cosine, they're the same, so that's why there's a plus sign, they get along, but sine and cosine are opposites, so that's why it's a negative. Just, one way you can remember that. Equals negative cosine y plus c, blah, blah. This, we can just split up, right? When you see a plus sign, boom, no need to worry about it, you can just split up that integral. So negative 1/2 integral of 1 plus, or rather, well, that's going to be iffy, okay, minus 1/2 integral cosine 2x. This is very simple. We're just going to get negative 1/2, sorry, dx, dx. Don't forget that. Integral of 1 is just going to be x, so times negative 1/2 is negative 1/2 x. Integral of cosine 2x, we use the chain rule. And if you don't remember that, I don't either. I just say that because everyone else does. So what we do is I just like to remember whatever's inside here for integrating, we just divide by it. So we're going to have negative 1/2 times, what's the integral of cosine? Sine. We keep the inside the same, and we divide by whatever's on the inside. Just, you know, the derivative of that, or just the coefficient in this case, 2. And here I like to put the plus c, so will technically be minus 1/2 c. So let's simplify this over here. Negative 1/2 x minus, minus 1/4 sine 2x minus 1/2 c equals negative cosine y. Now, from here, your book can do many different things, and I'll show you the two possible answers, the one where you put it in terms of y, and then what my textbook said. So what we can do is to just get rid of these fractions, we can divide everything by negative 4. This is going to become positive 2x. This will just become positive 1 sine, so plus sine of 2x. This c will become plus 2c, but since it's a constant, sometimes they might just keep it as c, and I'm pretty sure in here, yeah, they do. They just straight up do that. Yeah. Plus c equals, now what's negative 4 times a negative? Positive 4. 4 cosine y. So that is the solution that I see in my textbook, which I'm pretty sure is ZIL 9th edition. Now another way you could do this is to put it in terms of y. So we're going to I'm looking right here, and I'm running out of space, but I'll fit it. So we'll divide the entire thing by a negative, or multiply by negative 1, whatever you want to do. We'll get 1/2 x plus 1/4 sine 2x. The c will just, times a negative, we'll just keep it as plus. Since it's easy to lose track, I'll keep it as plus 1/2 c equals cosine y. And now you can remember, if cosine y equals something, then y is equal to inverse cosine whatever that something is. So now we can have our 1/2 x plus 1/4 sine 2x, and I'm running out of space, plus 1/2 c, and now they might just put it as c because constant times a constant is a constant. And that is how you do it implicitly, right, in terms of y. Now, depending on what your teacher asked, both might be the right answer, one might be the right answer, but these are, or at least they should be, equivalent to each other. I hope you learned something from this and have a nice day. Thank you for watching. Please feel free to leave any questions in the comments.